Testosterone, along with growth hormone and insulin-like growth factors, IGFs, plays a key role in muscle tissue growth and remodeling. This hormone is essential for various physiological processes, especially those related to muscle growth, strength, and adaptation to exercise. While testosterone is commonly associated with men due to its higher circulating levels in males, it is also present in women, albeit at much lower concentrations. When we think about testosterone in the context of muscle growth and strength, it's crucial to understand how it interacts with skeletal muscle tissue. Testosterone doesn't just float around aimlessly in the bloodstream, it binds to specific receptors on muscle cells. This interaction between testosterone and its receptor is what drives the anabolic or muscle building processes. While increased circulating testosterone in the blood can be an indicator of muscle activation and the body's response to exercise, it's the actual binding of testosterone to these receptors that triggers muscle growth. So even if testosterone levels don't spike significantly after a workout, the number of available receptors in the muscle may increase, which can enhance the muscle's ability to use the hormone for growth. Testosterone has both direct and indirect effects on muscle. Directly, it interacts with muscle cells to promote protein synthesis. Indirectly, it can stimulate the release of growth hormone from the pituitary gland, which further supports muscle growth. This hormone interaction highlights the interconnectedness of the body's systems, particularly the neuroendocrine and immune systems, which all work together to support muscle strength and size. Testosterone's influence isn't limited to just muscle. It also affects the nervous system, interacting with neurons to increase neurotransmitter levels and influence the structure of proteins within nerve cells. This interaction can enhance the muscle's ability to produce force, making the connection between the nervous system and muscle growth even more important. Now, what happens to testosterone during and after resistance exercise? Both men and women experience increases in testosterone levels following high-intensity exercise. However, the magnitude of these increases can vary. For men, resistance exercises that engage large muscle groups, such as deadlifts or squats, are particularly effective at boosting testosterone levels, especially when performed with heavy weights and short rest intervals. Women, on the other hand, generally experience much smaller increases in testosterone after resistance training, but their androgen receptors, where testosterone binds, are much more responsive. This means that even though women have lower testosterone levels, their muscles may still be highly sensitive to the testosterone that is available. One interesting point to consider is the influence of age on testosterone levels. In younger men, testosterone levels tend to increase more significantly after a workout compared to older men. This difference might be one reason why younger individuals generally build muscle more easily than older individuals. However, it's important to note that testosterone levels can fluctuate throughout the day due to normal hormonal rhythms, with the highest levels typically in the morning. Despite this, exercise can cause an increase in testosterone at any time of day, although the increase may be smaller if testosterone levels are already low. Testosterone responses in women are quite different from those in men. Women have significantly lower circulating levels of testosterone, and their increases in testosterone after exercise are often minimal. However, some studies have shown that women do experience small increases in free testosterone, the fraction of testosterone that is not bound to transport proteins and is biologically active after resistance training. Interestingly, despite the lower levels of testosterone in women, their androgen receptors tend to respond more quickly to the hormone, which may help explain why women still see benefits from resistance training even without large surges in testosterone. In a study conducted by Wingren and colleagues, both men and women participated in a resistance exercise protocol consisting of 6 sets of squats performed at 80% of their 1 repetition maximum, dx1rm. Blood samples were taken at multiple time points before the exercise session, midway through, immediately post-exercise, and at several intervals during recovery, 5, 15, 30, 70 minutes. The results showed a notable difference between men and women in their testosterone responses. As depicted in the graph, men experienced a significant rise in total testosterone levels, with concentrations peaking immediately after exercise. This increase gradually declined during the recovery phase, but remained elevated compared to pre-exercise levels. Women, on the other hand, exhibited only minimal changes in total testosterone levels throughout the entire session, with the concentration staying relatively stable. These findings highlight the pronounced difference in the acute testosterone response to resistance exercise between men and women, despite both groups engaging in the same workout protocol. While men show a marked hormonal response, women exhibit a much smaller fluctuation in testosterone levels during and after resistance training. Similarly, when examining free testosterone, the unbound form of the hormone that is biologically active, a comparable pattern is observed. Men displayed significant increases in free testosterone during and after exercise, with levels peaking immediately post-exercise. Meanwhile, the changes in women's free testosterone levels remained small and consistent throughout the session, as illustrated by the corresponding graph. This suggests that while resistance exercise has a substantial impact on testosterone levels in men, especially for free testosterone, women experience a much subtler response. Despite the differences in hormone levels, both men and women can still experience strength and muscle growth, with women potentially compensating through greater sensitivity to available testosterone due to a rapid upregulation of androgen receptors. Testosterone doesn't just work on its own, though. Free testosterone, which accounts for a very small percentage of the total testosterone in the body, is believed to be the most biologically active form of the hormone because it is not bound to transport proteins. This makes it more readily available to interact with receptors in target tissues like muscle cells. Resistance training has been shown to increase free testosterone levels, especially in men, but again, women show smaller increases. The concept of free testosterone is important because it suggests that simply having more total testosterone may not be enough to promote muscle growth. The free hormone hypothesis posits that only unbound or free hormones are able to exert their effects on target tissues. Therefore, it's not just the total amount of testosterone in the blood that matters, but how much of it is free and available to interact with muscle cells. As we look at how testosterone levels change in response to exercise, it's clear that both the type of exercise and the individual's characteristics, such as age and sex, play a role. In younger men, for example, resistance training protocols that involve multiple sets, large muscle groups, and heavy weights are particularly effective at increasing testosterone levels. These increases in testosterone help support muscle growth by promoting protein synthesis and enhancing the nervous system's ability to generate force. For women, the picture is a bit different. While testosterone levels don't increase as much as they do in men, women's muscles are still highly responsive to the hormone. The rapid upregulation of androgen receptors in response to exercise allows women to make the most of the testosterone they do have, supporting muscle growth and strength gains even without large increases in circulating testosterone. In conclusion, testosterone is a key player in muscle growth and strength development. It interacts with muscle cells to promote protein synthesis, supports the nervous system's ability to generate force, and works in concert with other hormones like growth hormone to enhance muscle growth. While men tend to experience more dramatic increases in testosterone in response to resistance training, women's muscles are highly sensitive to the hormone, allowing them to still see significant benefits from strength training. As research continues to explore the complex interactions between hormones and exercise, we will gain a deeper understanding of how to optimize training programs for both men and women to maximize their anabolic potential.